Hello learners, welcome back to our channel Robotics Labs. Have you ever wondered how a radar detects objects around it? Today we are going to build a miniature radar system using Arduino. It's a fun and exciting DIY project that scans nearby objects and display them on your computer just like a real radar screen. Before we begin, let's take a look at the components you will need. An Arduino Uno, an ultrasonic sensor, a micro servo motor, jumper wires, a USB cable, computer with Arduino IDE, processing software, and a 3D printed servo platform to securely mount the ultrasonic sensor. You can find all these electronic components in the Propellex Labs Young Innovators Kit. So let's get started. Let's move on to the connections. Connect the ultrasonic sensor. VCC to 5V on Arduino, ground to ground, trigger to digital pin 9, echo to digital pin 10. For the servo motor, red wire to 5V, brown or black wire to ground, signal wire to digital pin 6. Once everything is connected, double check all wiring carefully using the circuit diagram provided. Now let's assemble the radar. Start by fixing the servo motor onto the 3D printed servo platform. This platform keeps the servo stable and allows it to rotate smoothly. Next, mount the ultrasonic sensor on top of the servo using the sensor holder provided in the 3D printed platform. When the servo moves from 0 degrees to 180 degrees and back, the ultrasonic sensor moves with it, scanning the surrounding area just like a real radar. Once the hardware setup is now complete, open the Arduino IDE and upload the Arduino code. Let's understand what the program does. First, we include the servo library, include servo.h. Next, we create a servo object and attach it to digital pin 6. The servo rotates smoothly from 0 degree to 180 degree and then back again. At every angle, the ultrasonic sensor measures the distance to any object in front of it. The Arduino then sends two values to the computer through serial communication: angle and distance. This means an object is detected at 45 degrees and 30 centimeters away. So the Arduino performs three simple tasks: rotate the servo, measure the distance, and send the angle and distance to the computer. Now comes the most exciting part. Open the processing software and run the processing code. Processing continuously receives the angles and distance values sent by the Arduino. It then converts this information into a real-time radar display. Here is what you will see: a bright green scanning line sweeping across the screen. Whenever an object is detected, it appears as a glowing point on the radar. As the servo keeps rotating, the display updates instantly, creating a live radar effect. This gives us a miniature radar system that works very similarly to the scanning concept used in real radar technology. Now connect the Arduino to the computer using a USB cable. Select the correct board and port in the Arduino IDE and upload the code. Then run the processing program. If everything is connected correctly, the radar interface will appear on your screen. Now, move an object in front of the ultrasonic sensor and watch it appear on the radar display in real time. It's amazing to see both the hardware and software working together. With this project, you will learn how an ultrasonic sensor measures distance, how a servo motor creates a scanning motion, how Arduino sends data using serial communication, how processing converts sensor data into real-time graphics, how hardware and software work together to build an interactive system. If you enjoyed this project, don't forget to like, share and subscribe to Propellex Labs for more exciting DIY builds. Thanks for watching and we will see you in the next one.